Alright, scenario number 3. Dean is starting at the 5-meter mark by his house and is initially walking 1 meter per second towards the tree. Dean starts accelerating towards the tree at a rate of 0.5 meters per second each second. Predict the position when Dean is moving at a speed of 5 meters per second. So, we look at this, we know that Dean starts over at 5 meters and he's traveling towards a tree and he's getting faster. So, they would have known, alright, the location where Dean will be at when he's traveling at 5 meters per second. So we're just going to draw a dot diagram to represent that. Hey, look, we see Dean, we know he's getting faster as he goes from walking to running to the left. And since he's going to the left, he's heading in the negative direction. Alright, so his initial position would be positive 5 meters because it is the right of the origin. His initial velocity is going to be negative 1 meter per second because he's traveling to the left. The acceleration, since he's accelerating towards the tree, again, negative since it's to the left. So it'll be negative 0.5 meters per second. Time, we don't know about. Final velocity, it says it's at 5 meters per second, but since he's moving towards the tree, that implies that it is negative 5 meters per second because he's already heading to the left. And the final position is what they're looking for. Alright, if we look at this from a graphical point of view, if I look at my velocity versus time graph, we know that Dean starts at negative 1 meter per second, and he's getting faster at constant acceleration. So this will go, I'll start in the negative numbers, and I'll get larger to negative 5 meters per second. And the negative just means to the left in this case. The position versus time graph, he starts at a positive position, and he's getting faster, so we'll start at positive 5, and it'll be an upside down parabola, getting faster as he goes. Alright, now we have to determine where Dean is. So we have to find an expression that has the final velocity, the initial velocity, the acceleration, and the final position. And if you look down your list, you go through the first one, you have one that relates the initial velocity, the final velocity, acceleration, and time. Well, we can solve for time, but we're looking for final position. So if you go to the third one down the list, change in position equals VI delta t plus 1/2 at squared. Again, we can find for time, but still doesn't give us the final position because we don't have the time. So if you go to the last one, the VF squared equation, this would be the most appropriate one to use on that list because you have the initial and the final velocity. You have the acceleration, and all you need to solve for is the final position. Okay, so by substituting everything in, we have negative 5 meters per second squared is equal to negative 1 meter per second squared plus 2 times the acceleration, which is negative 0.5 meters per second. And then final position minus 5 meters. Alright, so now if we square the negative 5 meters per second, we get 25 meters squared over seconds squared is equal to 1 meter squared over seconds squared plus 2 times negative 1.5 meter per second, which would be negative 1 meter per second, times the quantity x minus 5 meters. Alright, subtract 1 from each side. You have 24 meters squared over seconds squared is equal to negative 1 meter per second times the quantity x minus 5 meters. Divide both sides by 1 meter per second. Alright, I'm going to bring this over here. That's a terrible arrow right there. And you have negative 24 meters is equal to x minus 5 meters. X will then equal -5